The talk coming up now is OWASP Top 10 in GraphQL, an API adventure. And Danielle Rosenfeld-Lovell is going to present it for us now. Thank you.
So, hello. And just a quick check, can everyone hear me across the room? Excellent. I know that it can be a little bit hard at the back, particularly if there's a lot of noise outside. I was listening to one yesterday. Right, so this is OWASP Top 10 in GraphQL. Thank you for coming. So I try not to labour this point too much. For those I haven't met yet, my name is Danielle. I work as a pen tester. I tend to have a pretty firm preference for working with web technologies, and I'm dabbling a bit in cloud and also secure code review at the moment. And when I'm not penetration testing, I'm a very proud cat mum to two extremely spoiled cats, and I knit prolifically wherever I can. So this is the overall summary. I had a couple of ideas in mind when I put this talk together. And really one of the primary targets for this talk were people who are dabbling in security, just getting to know the field a little bit. So firstly, web applications and APIs are really the bread and butter of what a penetration tester does day to day. A lot of the work coming through is going to be looking at web technologies, and these topics aren't necessarily always given the level of enthusiasm they deserve. And so following on from that, for anyone who has an interest in security and sort of wants to get a bit more acquainted with web tech, OWASP is something that comes up frequently, especially in job descriptions when you're looking for employment. So a knowledge of the OWASP Top 10 is very important and often very topical. And so I sort of thought, well, it would be really cool to do a run through of one of the OWASP Top 10 listings, focusing on a slightly less commonly encountered technology. And so that's what I'm going to be doing this morning. We're going to be looking at some GraphQL theory. So GraphQL is going to be our way of looking at OWASP Top 10. We're going to be introducing the OWASP Top 10 API security risks. And then we're going to use both GraphQL and a deliberately vulnerable GraphQL app as a vehicle for discussing the top 10. And specifically, before I go any further, when we talk about top 10, we're usually talking about top 10 for web application, which was released in 2021. But 2023, we had an API security risk listing. So I'll be working off of that slightly more recent listing of security risks for API specifically. Right. So that's all great, but what's GraphQL? And I'm glad that someone was thinking it. And GraphQL is just one of many options that you have for helping your web front end talk to a back-end server in a fairly controlled way. So we're having two technologies that are enabled to communicate with each other. We've got an API implementation strategy in this. And GraphQL is a cool technology. It's very widely supported across a range of frameworks and programming languages. Pretty much anything you could want to develop in at the moment, you will have an option to develop a GraphQL API. And it's actually been around for quite a while, even though it tends to feel like a fairly new technology. It was developed by Meta when Meta was still Facebook back in the dinosaur age, so in 2012. And it's particularly graphy, because you define this API schema or structure that turns out looking like some hierarchical tree-like thing. So you really have this encompassing of objects within objects, eventually terminating in fields, which are the concrete data that you're defining. So in the example diagram, we've got query, which contains a cat, very topical for me. And the cat may or may not choose to have an owner, and if it's lucky, it has its own fish. So this is where it gets a little bit more interesting from a testing perspective if you've done some application testing, but you've mostly seen REST APIs. So off the bat, I absolutely don't mean that you have to choose between RESTful and GraphQL, but there's one notable differentiator in the GraphQL case, and that's that you only have one endpoint when you're talking to a GraphQL API. You're interfacing with that one endpoint. Whereas in the REST case, you have resource orientation. So a core tenet of RESTful, if you haven't studied RESTful in a theoretical sense, is that RESTful APIs are resource oriented. So you have one unique URI per resource. And so in the example provided, we've had things like dog, and you might want to talk about a specific dog by ID. You might want to talk about that dog's bone, and so on and so forth. And the thing is that as soon as you end up with an even slightly complex system that you need to represent, you can end up with a lot of endpoints. And when you have a lot of endpoints, you need to be thinking about future refactoring of all those endpoints, and you need to be able to keep a track of all of those and maintain your inventory on all of those endpoints so that you don't accidentally leave something juicy hanging out on the internet. A really notable security win just off the bat for GraphQL, one endpoint, a little bit less inventory management in some respects. So from here on, just touching on a little bit of mission critical GraphQL theory. So first concept I'm talking about today is schema definition language. This is the way that we're talking in our GraphQL API. It facilitates transmission of information in the API in a human-readable JSON-like language. And this is what means that GraphQL can be implemented in this really language-agnostic way, where you have a GraphQL server that's going to talk, was going to be able to communicate with your queries using schema definition language. And in the cat example, we have a definition of an object, it's cat. It has fields, which will be defined at runtime as variables. Their name, color, weight, and loud. And there are just a couple of type definitions that are worth touching on. So in GraphQL, fields can be defined as objects. So the cat that has an owner. Fields can also be concrete data, and those are scalars. In GraphQL, scalars is a very broad church. It's not just numeric data. It's strings, booleans, floating point numbers, and integers. And one more type definition. So you have the ability to define enums in GraphQL. So that means that you can actually self-define a list of named values. So in the color example, we could redefine that as an enum. We could select beige, white, black, whatever. So concept the second is how to do CRUD. So what I'm talking about is core API operations that facilitate persistent storage of data. So create, read, update, and delete. And the two more commonly encountered operation types in GraphQL are query and mutation. Query handles reading of data. So if a user wants to wants to access their own account data, they're going to be using a query operation type. And mutation, which handles all data change. So object creation, deletion, and updating of the variables associated with an object that we're changing. And just for awareness, there's one more operation type in GraphQL, that's subscription, that handles circumstances where you have some need to do real-time updates on a system. So you might have like an emergency notification system through SMS or something like that. It's a little bit less applicable for the purposes of this talk, so I'll just leave that there as is. And as a bit of a heads up, from here on in, I'm going to be looking at some request and response pairs from Damn Vulnerable GraphQL app, which is credited at the end of the presentation. So I promise nothing but the silliest of examples for the rest of this presentation. And we're going to be talking about them in terms of OWASP Top 10 for API. Now, the good thing about Damn Vulnerable GraphQL app is that for anyone who hasn't done API hacking in the background before, it's really easy to set up locally just using a publicly available Docker instance. And for a bit of context as well, what you're looking at in terms of what this application represents is a public messaging forum. So you can post public comments, private comments, and in this context, they call them pastes. So I'm going to align with their language and use pastes as what I'm talking about. So as an example, this is a query operation type. And just noting the use of the query keyword, we've read all public pastes from this system. And this is a mutation operation type. So again, this is what's used to change data, or in this case, create an entirely new object. So this is a new public paste that's been created using, again, that mutation operation type that's referenced. Now, the third concept I'm going to touch on today is introspection, which is really important in GraphQL. So introspection in a computational sense, we're talking about, something that's very much like personal introspection, where you're looking inside, thinking about your thoughts and feelings and processes, and analyzing why you have them. So if introspection is enabled, it allows you to directly query the schema and get all of the information you need about how to use the API and what queries you can run. And in GraphQL, introspection is enabled by default. Okay, and here's an example request-response pair where we've actually run an introspection query. And just with that one request, we've been able to capture all of the information about the defined types that we have for this API. So it gives you a really good understanding of what you can do functionally with this API. And for a bit of context as well, if you haven't done API testing, this is something that could actually take days, if not quite a lot longer, for a really complex API in the RESTful case, because you're having to actually do content discovery across all of those endpoints in the first place. And in this case, it's actually been handed to us on a platter, which is really cool. Okay, so moving on to the top 10 content. So OWASP stands for Open Worldwide Application Security Project, makes heaps of publications, very famous for the top 10 for web applications, last updated in 2021. There are a couple of really notable strengths of OWASP documentation, in my opinion, and they are that, firstly, OWASP documentation often tends to be quite directed towards developer audiences. And as such, another really core strength is that issues in this listing and in other listings tend to focus a bit more on root causes and also business logic failures, which is notably different from some frameworks which focus more specifically on vulnerability classes. So I'll get straight into it now, and moving on to API 1, which is broken object level authorization. Also known as BOLA, historically known as IDOR, or indirect object references. It involves some improper ability to read or change something at the object level. And as an example, I've got this public paste, and it's by Carleen. It turns out that there's a really easy to enumerate object ID associated with this paste, and you find out that you can actually mutate the paste and deface anyone's public paste across this entire system, because there is no authorization control in this lab environment. So that's a clear failure. API 2 is broken authentication. And again, because this is a lab environment with a relatively simple architecture, we actually really don't have authentication in the first place, which makes it really hard to tie a user's identity to some sort of session ID. But as a bit of an example of what this might look like, so authentication failures can be things like login bypass particularly, or if you've been able to change the value of a cookie in a way that's given you excessive privileges. So I've taken this cookie, for instance, and originally I found this GraphQL development environment as part of this environment. And that's really cool because it allows me to run queries in a very user-friendly way and do tab autocompletion to look at all of the types and all of that sort of thing. And you can simply go in, you find that there's some sort of access control on this system. You can't run queries out of this environment in the first place, but simply by changing the value of the cookie from disable to enable, suddenly you've bypassed the only thing that looks vaguely like any sort of authentication or authorization control. Now, API 3 is the second of the specifically authorization failures in this listing. And so what if I want to see every other user's public IP address in the system, and it turns out I totally can, which sounds very bad. Broken object property level authorization occurs at the level of a field, or specifically a variable within your object. There are two subclasses of this problem. So the first is excessive data exposure, which is clearly what's happened here. The second, slightly more interesting one is mass assignment, which comes up all the time in API testing, where you have some hidden parameter or field that can be identified and potentially manipulated in some unintended way. And in lab contexts, often you'll see that as there's a role parameter, for instance, and you can actually change the value of role to something like admin, where that role wouldn't have been introduced in the first place in your request. Unrestricted resource consumption is API 4. So this is where you can tie up computational resources to create a denial of service, or potentially you can cause truly excessive use of pay-as-you-go resources, dialing up operational expenses for an organization. And GraphQL has a couple of particularly notable susceptibilities to this issue. The first susceptibility is that you can query batch in GraphQL. So that means you can essentially just stack a bunch of queries into the same request. And that ultimately means that you can bypass restrictions that would be applied so that you can limit the number of requests that you can have sent. So you're basically just stacking all of these requests into the same you're stacking all of these queries rather into the same request and sending them off at the same time. And in GraphQL, they're going to be processed in parallel, so all together, all at once. And then the second notable susceptibility is denial of service by recursion. So because we have this sort of hierarchical tree-like structure, we can really nest queries within queries, which can make for something that's really resource intensive, potentially causing a denial of service. And the good news, on the other hand, is that we have a couple of very well documented workarounds to all of these things. So you can, for instance, add limits to the maximum query depth you'll process, and that can address the denial of service by recursion case. You can apply request timeouts. So if the request takes more than a certain amount of time, up to a fixed limit, we're just going to drop it. We're not going to process it anymore. You can also return cached responses so that you're not having to reprocess the same query that might be particularly popular multiple times. And finally, you can apply cost analysis to a query before it's processed. So we're going to actually factor in how resource intensive that query is in the first place before we even process it. Just an aside as well, that can actually be fairly computationally expensive and slow down your response time in the first place, so you have to apply it on a case-by-case basis. And API 5 is the last of the authorization failures in the list of 10. So imagine that you've left some absolutely godlike operation accessible that was meant to be used by admins, so something that's a specific sort of all over the system functionality. And in the example, it turns out that you can make a call to delete all pastes. And thinking that it was just my own public pastes that I'd be deleting, I run this, and it turns out I delete everyone's comments across this entire system ever. So then moving on to API 6, unrestricted access to sensitive business flows. This occurs where you have some ability to trigger sensitive business functionality using an automated tool. So, for instance, I've been able to span this message board with 100 comments. This is a really, really silly example. However, something that's a little bit more topical at the moment might be where you've had bots used to purchase concert tickets to Scout. So if anyone was looking for Era's tour tickets, that was very much in the media recently and very much a problem. Now, making sensitive business processes multi-step can make this sort of exploitation harder, where you're not just having to trigger one single API call. But as an aside, an attacker can very easily use a script to automate a multi-step process if they care enough about the target in the first place. So it really requires a more comprehensive solution. Now, API 7 is notable because it's the only specific vulnerability class that really gets touched on in this entire list of 10. And that's server-side request forgery, which speaks to how important it is. Server-side request forgery, where you can access, where you can use a part of the application to access some network resource in an unintended way. So you can access things that are internal, restricted, and in the example, I've used a vulnerable file import functionality to actually access a web service running on my local device. And as a bit of background as well, in real scenarios, this level of easy is basically, not something that I've ever seen. But you do get a lot of inference-based server-side request forgery issues cropping up where you have to do quite a lot of additional investigation. API 8 is security misconfiguration, a tremendously broad church. Introspection, remember her? She's back. So turns out perhaps we've been able to identify some very, very secret administrative functionality that ideally shouldn't have been handed to us on a platter as a hacker. API 9 is improper inventory management, phenomenally important. That's where we have some poor visibility over what a product does, where there are two subcategories of this issue defined in the OWASP documentation. That's where you have some documentation blind spot is the first, where documentation either hasn't been generated for a product in the first place or it hasn't been maintained after it was initially published. And data flow blind spots, potentially where you have some sort of data flow between your app and a third-party service, but you have pretty poor oversight over what that data flow actually looks like, what it does, and whether it's justified from a business perspective in the first place. And finally, made it. It was a bit of a mouthful. So API 10 is the last of our API OWASP top 10 risk categories. Now, that's unsafe consumption of APIs, and I didn't have a particularly good example of this in a lab context, and I imagine virtually in any lab context because you end up with these pretty simple architectures. But this occurs where you have an interaction with third-party services again, and you've provided excessive trust to that third-party API. So for instance, you might consume data from a third-party API without any input validation, leading to injection vulnerabilities on your application. Or you might share sensitive data with a third-party service and you don't check that third-party service applies the same rigors of protection to the confidentiality of the information you provided. So in conclusion, GraphQL is really, really cool. It's very flexible, it's elegant, it has fantastic support, and a particularly notable difference from a testing perspective is that you're interacting with a single endpoint as your interface. OWASP Top 10, unsurprisingly, applies just as much for the GraphQL case as it does for other API architectures. And there are just some notable differences when you're testing GraphQL because of GraphQL-like quirks like introspection, for instance, using mutation for all data change, and how much direct control you have within the query over the application logic. And I don't think we're necessarily going to have a lot of time for questions, but I'll leave that up to Josh and resources.